And now in this lecture we'll find out the area of rectangle ABCD that blocks a circle. In the drawing we have rectangle ABCD. Inside this rectangle ABCD we have this circle. This circle is inscribed by rectangle ABCD. We also know that chord EF equals to 12 units in its length. Line segment FQ equals to 10 units in its length. Again, our mission is to find out the area of this rectangle ABCD that blocks this circle. So first of all the angles inside a rectangle are right angles, so this angle is a right angle. We define the radius of this circle as R. And point O is the center of this circle. Point M is the point of tendency of tangent DC with this circle. Point E is the point of tendency of tangent AD with this circle. And point N is the point of tendency of tangent AB with this circle. So here we have tangent DC again is tangent to this circle at point M. So we join points O and M together by a straight line. Point O is the center of this circle, point M is the point of the circle itself, therefore OM is the radius of this circle, that is equals to R according to our definition. The radius OM is drawn to point M, that is the point of tendency of tangent DC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent DC will be perpendicular to the radius MO. If this is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. Likewise, we join points O and E together by a straight line. OE is of course the radius of this circle that equals to R. And because of the fact that the radius OE is drawn to point E, that is the point of tendency of tangent AD with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AD will be perpendicular to the radius EO. If AD is perpendicular to EO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside the small quadrilateral DMOE we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4/5 again, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this 4/5 angle must be equal to 90 degrees in its size. So inside quadrilateral DMOE we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be a right angle if not a square. So we know for this quadrilateral DMOE is a rectangle because it has 4 right angles. Likewise, we join points O and N together by a straight line. ON is of course the radius of this circle that is equal to R. And because of the fact that the radius ON is drawn to point N, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius A and O. If AB is perpendicular to A and O, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. according to rule 1. So actually we have here the small quadrilateral EONA. Inside this small quadrilateral EONA we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees. So 270 degrees plus the size of this 4-fifths angle, in total they must be equal to 360 degrees. Therefore this 4-fifths angle must be equal to 90 degrees in its size. So actually found out that angle, the big angle MON equals to 90 degrees plus 90 degrees, that is 180 degrees. So if you know, the big angle MON equals to 180 degrees in its size. And you know that any angle that is equals to 180 degrees in its size, it is defined as a straight line. That is to say, line segment MON is a straight line. If line segment MON is a straight line, then MN also must be a straight line. So MN is a straight line also. So MN is a straight line that touches the circle at 2 points, M and N. Therefore, MN is a chord. MN is a chord. But MN is a chord that passes from point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, in total we found out that MN is the diameter of the circle. MN is the diameter of the circle. Quadrilateral DMNA has 4 right angles, and therefore, according to rule 5, any quadrilateral that has 4 right angles must be a rectangle in front of square. So we know to quadrilateral DMNA is a rectangle because it has 4 right angles. So I write it down. Quadrilateral DMNA is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side MN must be equal to the opposite side DA. So MN equals to DA. So MN equals to DA, so I write it down. MN equals to DA. In rectangle DMNA, MN equals to DA. But MN is the diameter of the circle. MN is the diameter of the circle. You can write here that MN is the diameter of the circle. And for this equation, the diameter equals to MN equals to DA. We derive that DA is also the diameter of the circle. DA is the diameter of the circle. DA is the diameter of the circle, and DA is also the width of rectangle ABCD. So it is the diameter of the circle and it is also the width of rectangle ABCD. Okay, you know that the length of rectangle ABCD equals to AB, and the area of rectangle ABCD equals to the width times the length. So if we found out that AD is both the diameter and the width of rectangle ABCD, and AB is the length. In the next step, we'll extend the radius EO by straight line until it touches the circle. And we will define the touching point of the extended radius EO with this circle. This point is point L. So actually, EL is a chord that passes through point O, that is the center of this circle, and we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, EL is the diameter of this circle. So write it down. EL is the diameter of the circle. EL is the diameter of the circle. And we know that DA is also the diameter of the circle. EL is the diameter of the circle, and DA is also the diameter of the circle. And from this equation, EL equals to the diameter equals to DA, we derive that EL equals to DA, or DA equals to EL. DA equals to EL. DA equals to EL. That is to say, the width of rectangle ABCD equals to EL. AD is the width, and it is equals to EL. Therefore, EL is the width of rectangle ABCD. So write it down. EL is the width of rectangle ABCD. In the next step, we will extend the diameter, but before that, we will join points F and L together by straight line. By joining points F and L, we created a peripheral angle LFE. This peripheral angle LFE subtends on EL, that is the diameter of the circle. EL is the diameter of the circle. And we know that any peripheral angle that subtends on the diameter of the circle must be equal to 90 degrees in its size. According to rule 7, if a peripheral angle subtends on the diameter of the circle, then it is equal to 90 degrees. The drawing here is a circle. This is peripheral angle ACB that subsets on AB, that is the diameter of the circle. Therefore, peripheral angle ACB is equal to 90 degrees in its size. So here, peripheral angle LFE subtends on EL, that is the diameter of the circle, and therefore peripheral angle LFE must be equal to 90 degrees in its size according to rule 7. The next step will focus on the small right triangle ELF. We define this angle as alpha. So in the right triangle ELF, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this frequency angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step, we will do a construction. That is to say, we will extend the radius EL by a straight line until it touches side CV of this rectangle ABCD. Actually, draw the radius EO, then we extended the radius EO to the diameter EL, and then we extended the diameter EL by a straight line. When we extend a straight line by a straight line, the result is a straight line. So we define the touching point of the extended diameter EL with this side CB as point H. So we extended the diameter EL, that is a straight line, by straight line, and therefore the result is EH, therefore it is also a straight line. So EH is a straight line. So inside quadrilateral EHBF we have 1, 2, 3 right angles. Again, the sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4th angle, in total it must be equal to 360 degrees, and therefore this 4th angle must be equal to 90 degrees in its size. So inside quadrilateral EHBA we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to the big quadrilateral EHBA is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle EHBF, side EH must be equal to the opposite side FB. So AB equals to FH. So we can write here that AB equals to FH. That is to say, the length of the rectangle ABCD is equals to EH. The length of rectangle ABCD equals to EH. Again, those two opposite sides in rectangle EHBA are equal to each other, and therefore side AB equals to side EH. Side AB equals to side EH. Side AB equals to side EH in rectangle AHE AB. But side AB is the length. So we can write here that side AB is the length. And from this equation, the length equals to AB equals to EH. We derive that EH is also the length of rectangle ABCD. EH is the length of rectangle ABCD. And we already found out that EL is the width of rectangle ABCD. And you know that the length times the width is the area of rectangle ABCD. That is the area that we are looking for in this question. Okay. In the next step, we will focus on the right big triangle, triangle EHB. In the right big triangle we focus on the right big triangle EHG. This right big triangle. In the right big triangle EHG, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. It is very easy to say that the small right triangle ELF is similar to the big right triangle EHG. So, why those two right triangles are similar to each other? First of all, this is angle alpha, that is a common angle that belongs to both triangles. Angle alpha belongs to the small right triangle ELF, and angle alpha it also belongs to the big right triangle edge EG. So this is a common angle that belongs to both triangles, so we can write down that angle alpha equals to itself as a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So in total, we should find out that the big right triangle EHG is similar, this is the sign of similar, to the right small triangle ELF. And they are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side EH in the big right triangle EHG over side EF of the small right triangle EFL is equal to side EG of the big right triangle EHG over side EL of the small right triangle ELF. Repeat again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side EH of the big right triangle EHG over side EF of the small right triangle ELF equals to side EG of the big right triangle EHG over side EL of the small right triangle ELF. EH is the missing side, so leave it as it is. Over EF. EF is equals to 12 units in itself according to what is given us in the question. So we'll substitute EF by 12, and it is equals to EG. EG in total equals to 12 plus 10, that is 22. Again, EG equals to 22 according to what is given us in the question, because it is 12 plus 10, that is 22. So we substitute EG by 22 over EL. EL is the missing side, so we leave it as it is. So in total, we should find out that EH over 12 equals to 22 over EL. Here we'll cross multiply this equation, and we get that EH, so I write it here, EH times EL equals to 22 times 12. And again, I shall find out that EH times EL equals to 22 times 12. 22 times 12 is 264, and it is equal to EH times EL. We have already found out that EH is the length of rectangle ABCD. So we substitute EH by the length times EL. We already found out that EL is the width of rectangle ABCD. So we substitute EL by the width. So in total we found out that the length times the width of rectangle ABCD is equal to 264. What is the length times the width? It is of course the area of rectangle ABCD. That is the area that we are looking for in this question. So it is the area of rectangle ABCD. Is equal to 264 square units. And that is the answer to the question. Repeat again, we have found out that the area of this rectangle ABCD is equal to 264 square units. So in the next step, I'm starting the lecture. So in this lecture, I found out the area of this rectangle ABCD that blocks this circle. That is to say, this circle is inscribed by rectangle ABCD. In addition, you know that this is called EF, that is equals to 12 units in its length. This is line 7 FG, that is equals to 10 units in its length. Again, our mission is to find out the area of this rectangle ABCD. First of all, we know that all the angles inside rectangle ABCD are right angles. So this is a right angle. And we know point O is the center of the circle. Side DC is tangent to this angle at point M. Side DA is tangent to this angle at point E. And finally, side AB is tangent to the circle at point N. Again, point O is the center of the circle. We join points O and M together. We join points O and N together by side line. Point O is the center of the circle. Point N is the point on the circle itself. Therefore, O1 is the radius of this circle. That is equals to R according to our definition. The radius of the circle is R. And because of the fact that the radius ON that is equals to R, the radius ON is drawn to point N, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius NO. If AB is perpendicular to NO, then this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, join points O and E together by side line. O is the radius of the circle that is equals to R, and because of the fact that the radius OA is drawn to point A, that is the point of tendency of tangent DA with this circle, whenever your radius that is drawn to the point of tendency, then tangent DA will be perpendicular to the radius DO. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, you join points O and N together by side line. OM is the radius of the circle that is equal to R, and because of the fact that the radius OM is drawn to point M, that is the point of tendency of tangent DC with this circle, and whenever your radius that is drawn to the point of tendency, then tangent DC will be perpendicular to the radius MO. If this is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So, inside the small quadrilateral DMOE, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 facing angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees in its size. Likewise, inside the small quadrilateral EONA, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, so 270 degrees plus the size of this fourth missing angle must be equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So in total, we found out that the big angle MON equals to 90 degrees plus 90 degrees, it is 180 degrees. And again, if we found out that the big angle MON equals to 180 degrees in its size. We know that any angle that is equal to 180 degrees in its size must be a straight line. Therefore, line segment MON is a straight line. If line segment MON is a straight line, then MN is also a straight line. MN is also a straight line. So MN is a chord that touches the circle at 2 points, M and N, and therefore we know that any chord that passes, and we know that it passes from point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, MN is the diameter of the circle. MN is the diameter of the circle. So, in quadrilateral DMNA, we have 1, 2, 3, 4 rectangles. Therefore, we can relate to quadrilateral DMNA as a rectangle. Quadrilateral DMNA is a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side MN must be equal to the opposite side DA. Okay? MN equals to DA. So we have here MN equals to DA, according to the rule that the opposite sides of a rectangle are equal to each other. MN equals to the opposite side DA from one side, but from the other side, we have already found out that MN is the diameter of the circle. MN is the diameter of the circle. MN is the diameter of the circle, and from this equation, the diameter equals to MN equals to DA, we derive that DA is also the diameter of the circle. DA is the diameter of the circle. This is side DA, that is the diameter of the circle. In the next step, we extended the radius EO by a straight line until it touches the circle. At this point, we define the touching point of the extended radius EO with this circle. This point is point L. So, EL is a chord that passes through point O, that is the center of the circle. We know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, EL is the diameter of the circle. EL is the diameter of the circle because it passes through point O, that is the center of the circle, from one side. But from the other side, we already found out that AD is also the diameter of the circle. So we can write here that AD is also the diameter of the circle. And from this equation, EL equals to the diameter equals to DA, we derive that DA equals to EL. Or we can derive also that EL is also EL is the diameter, also the diameter of the circle from one side, but EL is the width. Okay, EL is the diameter of the circle, and it is equals to DA. So DA is the diameter of the circle, and therefore the width AD is also the width of this rectangle ABCD, And therefore we derive that the diameter of the circle equals to the width, and because of the fact that the diameter is also the width, we derive that the diameter, the width is also equals to EL. Okay, because EL is the diameter of the circle, and the width is the diameter of the circle. Therefore, EL is the diameter, EL is the width. Okay, EL is the width. EL is the diameter of the circle, and DA is the width. Here, DA is the width. DA is the width of rectangle ABCD. And again, DA is the width of rectangle ABCD. DA is the width. And from this equation, EL equals to the diameter equals to DA equals to the width. We will derive that EL is also the width of rectangle ABCD. EL is also the width of rectangle ABCD. So this is EL, that is the width of rectangle ABCD. Okay. In the next step, we extended the diameter EL by a straight line until it touches side CB of rectangle ABCD. We define this touching point of the extended diameter EL with this rectangle ABCD. This point is point H. So EH is one straight line because we extended the diameter EL by straight line, and the result, when you extend the straight line by straight line, the result is straight line. So EH is one straight line. So inside the rectangle, inside the quadrilateral EH BA, we have 1, 2, 3 angles. Those two angles are right angles because ABCD is a rectangle, and this angle is a right angle according to rule 1. So in total, in rectangle, in quadrilateral edge EAB, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the side of this 450 angle, in total they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this 450 angle must be equal to 90 degrees in its size. Therefore, in quadrilateral EHBA, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to quadrilateral EHBA as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle EHBA, side EH must be equal to the opposite side AB. So EH must be equal to AB. EH equals to AB from one side, but for the other side, we know that AB is the length of rectangle ABCD. So we can write here that AB is the length of rectangle ABCD, and from this equation, the length equals to AB equals to EH, we derive that EH is the length of rectangle ABCD. So in total, we should find out that EL is the width of rectangle ABCD, and EH is the length of rectangle ABCD. And you know that the length times the width is the area of rectangle ABCD, that is the area that we are looking for in this question. So here we have the big right angle EHG. We define this angle as alpha. So in the big right angle EHG, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. And 90 degrees plus 90 degrees, it is equal to 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in the rectangle. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Likewise, in the small right angle ELF, this angle equals to alpha, this angle equals to 90 degrees according to rule 7. And therefore, this third missing angle must be equal to 90 degrees minus alpha. So it is very easy to see that those two right triangles, that is to say the right big triangle EHD is similar to the right small triangle ELF. So why those two right triangles are similar to each other? First of all, this is angle E, that is a common angle that belongs to both triangles, so I can write down that angle E is equals to itself. It's a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So I shall prove that all the figures of the right big triangle EHG are correspondingly equal to all the figures of this right small triangle ELF. And therefore, those two right triangles are similar to each other according to angle similarity rule. So I repeat again, the big right triangle HGE is similar, this is the same of similar to the right small triangle ELF according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we know that the following relationship exists between their sides. The side E edge of the big right triangle EHGE over side EF of the small right triangle ELF is equal to side EG of the big right triangle EGH over side EL of the right small triangle ELF. Again, we derive the side E edge of the big right triangle EHG over side EF of the small right triangle ELF equals to side EG of the right big triangle EHG over side EL of the right small triangle ELF. EH is the missing side, so leave it as it is, over EF. EF is 12 units in its length, is equal to 12 units in its length according to what is given as the question. So we substitute EF by 12. And it is equals to EG. EG in total equals to 12 plus 10, that is 22. So we substitute EG by 22 over EL. EL is the missing side, so we leave it as it is. So in total, we found out that EH over 12 equals to 22 over EL. Again, we found out that EH over 12 equals to 22 over EL. Here we cross multiply this equation, and finally found out that EH times EL equals to 22 times 12. 22 times 12 is 264. We have already found out that EH is the length of rectangle ABCD. So we substitute EH by the length. And EL is the width. So we substitute EL by the width. EL by the width. So in total, the length times the width is equals to 264. The length times the width is the area of rectangle ABCD. So we found out that the area of rectangle ABCD is equal to 264 square units. Okay, thank you very much.